Okay, it's Ron here again, Professor Ron, and I call this short little video probability problems because the information that I'm going to give you in a minute here is really going to deal with three kinds of probability. Normal distribution, which is the one that you're going to use the most outside the classroom. Binomial distribution, which is also used quite a bit, and the last one is Poisson distribution. The three of these distributions have one super important thing in common, and that is that if you took all of the data that you were given and you created on a graph, you marked off everything, what you would get when you drew the graph is a parabolic curve. Fancy words, right? It's called a bell curve. Looks like a bell. Skinny bells mean the data is all close together. Spread out bells mean it's spread more apart. In either case, you're looking at a bell curve. And if you look at the bottom part, you'll notice the Greek letter O with the term standard deviation. And along the x-axis of the graph, you'll see that the standard deviations shown going from -3 to +3. Those standard deviations account for about 99.6 or 7% of everything that you're going to see in the graph. And that's more than enough. You really don't have to go any further than that with greater standard deviations when you're trying to calculate probability. The other thing is, if you look at the graph now, the Greek letter U equals the average, the mean. So if we look above at the problem where it says the average height of the cherry trees is 11 feet, that would be the top of the bell. So what you're looking at is where the arrow is pointing, where it says the average height of the cherry tree is 11 feet. That's the very top of the bell, and you'll notice there, if you go down to the x-axis from there, that's at the point where standard deviation is 0, because it's 0 at the average. So that's basic stuff that applies to all of the graphs that you're going to be creating and looking at to go ahead and solve your problems. Now it says if the heights are normally distributed with a standard deviation of 1.6 feet, your problem here is to find the probability that a tree is 13 feet tall or less. This, by the way, is a problem just in normal distribution. You'll notice how the problem is stated. It says if the heights are normally distributed, which is telling you that's how you're going to identify that you're going to do a problem in normal distribution. Now you'll notice that the arrow is approximately at 13 feet. Now remember, at 0, that's 11 feet. That's the average. And if we move to the right, following the standard deviation that we're given at 1.6, that black vertical line represents 13 feet. Okay. If you look now at the arrows that have gone in there, the area of that belt, between those areas, stopping at the vertical line, which represents 13 feet, whatever that is going to be the probability that you're going to be looking for, and that's going to solve your problem. Okay? Now, the original problem was this, that the height was, average was 11, and you were going to look for 13 feet tall or less, okay? That's what the original problem is. But what if it was asked almost the same thing, but now you're being asked that the probability is 13 feet tall or more. The first one was less, and now is more. So when you look at the graph, the first time we looked at the area to the left of the black vertical line. Now, for this question, we're looking for the area to the right of the vertical line, okay? That's the difference. The good news here is that this bell represents 100% of all of the probabilities. So you calculate the part of the bell you're not interested in. That's why it's in red and it's bold. And then you subtract your answer from 100%, and you'll get the percentage represented by the area to the right of that vertical line. It sounds confusing maybe, but it really isn't. It enables you then to solve problems in normal probability or Poisson or binomial, whether it's more than, less than, or in remote cases, just equal to. And I'm giving you this set of instructions, and then I'm going to go into how you solve normal distribution problems. What I've told you here is that you're looking at a couple of things. Along the bottom where it says -3 to +3, that's a designation for standard deviations. At the height of the bell, where you're looking at the Greek U, that represents the average. And when you look at your formulas and how you have to enter stuff into Excel to solve problems, they're going to use those designations. So when you see the Greek letter U, you're going to enter the average. Where you're asked for standard deviation, which is going to be the Greek O, you'll know what it is that you want to enter. So that's what I've indicated here, and the arrow points to the area that you're looking for to solve this second problem, which would be that area which is to the right of the vertical line, which represents the 13 feet. The area to the right is 13 feet or more. The area to the left is 13 feet or less. So we kind of file that away when we get into actually going in and solving problems. Thanks for watching this instructional video. And you'll notice I called it lecture/instructional video, because instead of just being straight instructions, there's a lecture along with it that will help you to gain more knowledge of the subject. All of the videos, by the way, that are on my website. The address of the website is shown on this slide right now. And also, I invite you to please enter any comments or questions you had about the video in the area below the screen. And what's most important to me anyways is to have you subscribe to my channel in order to get copies of new videos as I post them. To do this, you'll need a Google email address. And if you don't have one, YouTube should walk you through what you need to do to get one if you don't already have one that you use. Certainly, in addition to anything else, your input is going to help me to improve the stuff I'm presenting. So any comments that you have will be appreciated. A thumbs up is what I would hope for, but if there are things that you think need improvement, give me a thumbs down and tell me what it is that I need to do to make these videos mean more for you. Thanks again for watching.